All right, this is the Unit 3 Solid Geometry, Math 3 assessment review for our test. That's coming up. I'm going to use both the TI-84 calculator, probably mostly, but then some Desmos. I'll show you a little bit of that because you can use both. But most of the stuff in this unit is just calculations. We're not really looking at graphs. All right, number one, Jesse found a piece of material that has a mass of 31.68 grams if he fills up a glass with 20 milliliters of water. Once he drops the material into the glass, the water level rises to 32 milliliters. What is the piece of material made of? Justify your answer. Okay, so here we're talking about density. All right, when you start seeing like centimeters cubed, milliliters, and like the mass of something, remember density equals the mass divided by the volume. All right, now volume is like anytime you see cubic centimeters, cubic inches, any of that, that's the volume. All right, so notice this right here. Do you notice how the water level went from 20 to 32 milliliters? So when I subtract that, 32 minus 20, sorry, is 12. All right, milliliters. But remember, hint, 1 milliliter water equals 1 centimeter cubed. So really, this is 12 cubic centimeters. All right, that is, think of it as the volume of it. All right, so now here's our mass. So mass over volume. So the mass is 31.68 grams divided by 12. All right, so we're going to take our calculator and we're going to say, let me clear it out. All right, 31.68 divided by 12. And what do we get? We get 2.64. All right, so the density is 2.64 grams per cubic centimeter, or you can say grams per milliliter. Okay, so what does this match up with? If you notice, it matches up with quarts. So the piece of material must be a quartz. And the ratio of the mass, which was 31.68, to the volume, which we found to be 12 centimeters cubed, or you can say 12 milliliter, gives the density of the piece of material. All right, so that's what math that we actually did. All right, moving right along. A cube with a cylindrical hole cut out of the middle of the cube is shown. So you got a cube. What do you know about a cube? All the sides are alike. All right. The edge length of the cube is 12 meters. So if this is 12, then all of these are 12. And it says the circle on the front face of the cube has a diameter of 4. So wait a minute. If we know the diameter, what else do we know? We know the radius is 2, because remember, all of our radii formula, or all of our formulas use radii. All right. So the radius is 2. So I'm just going to draw it halfway. All right, find the volume of the figure. Well, first off, you got the cube. The cube is the big thing. All right, so how do you find the volume of cube? Length times width times height. Okay, 12 times 12 times 12. All right, so when I do this, let's see, 12 times 12 times 12. All right, so 1728. All right, 1728. All right, this is in meters, so we could say meters cubed. Well, now think about it. I have to now find the volume of the cylinder. Okay, now the formula for the volume of a cylinder is pi r squared h. All right, so pi, the radius is 2, and then you square it, but then the height, think about it. This is laying on its side. What is that length right there? You said a length of 12, you're correct. Now, I didn't say this on here, but I'm going to round to the nearest 10th. Now, what do I do here? Did I just piece this together so I would add them, or did I have to take something away? If you said take it away, you are correct. And so when we take something away, we subtract. Order matters right here. Okay, so you can actually take your calculator and plug all these in at once. All right, so I can take the 1712. I've already got it in my calculator. So if I just hit minus, it puts that answer in there. Okay, and now I can say pi. If you're using these calculators, pi is second, and then the caret symbol. All right, and then 2 squared, and then times 12. All right, the squared symbol, if you want to know, is right here beside the comma, and press enter. So I said we're going to round to the nearest tenth, so that's 1 decimal place. So 1577.2 meters cubed. All right, to the nearest tenth is 1 decimal place. All right, moving right along. Find the volume of the composite figure. Composite figures, all of these right here are composite figures when they're made up of more than one object. Here, we've got two rectangular prisms. All right, we just need to add them together. Now, you need to divide it. Now, there were some X and Y's that this picture gave. We don't have those values. Just think about it for a second. If you want to, you could divide it this way. Okay, or you can do it on a dotted line. So here I've got 2. And just think in a rectangular prism is length times width times height. So I'm going to get this top one. All right, the length, all right, is 33. This part they tell us is 72. So 33 times 72. All right, and then times the height is 21. All right, so that's one of them. So if I go 33 times 72 times 21, I'm just doing it off to the side, you should get 49,896. All right, now if I'm doing this figure, all right, well, the question is, how much is this part right here? All right, let's look. How much is that part right here? Do you see that it's like the same width as if this going back? So this is actually 33. All right, so the length of that is 33. The width right here is 18. And then the height. Sometimes you have to figure out the height, but they're telling us this much is 39. So right here is 39. Okay, so if I do 33 times 18 times 39, I'm going to get 23,166. Now, this time I'm not taking anything away. All right, so here I'm piecing them together, so I'm going to add the 2 together. So when I add these 2 together, I get 73,062, and then this would be centimeters cubed. All right, our next figure, think about what it is. We have a rectangular prism, so I'll just put prism. That we just did rectangular prism, length times width times height. All right, and then we have a pyramid. And think, pyramid, and I might have just spelled this wrong. Okay, pyramid, do I add or do I subtract? You add. And the volume of a pyramid is big B times H divided by 3. Anytime it comes up to that point, that apex or that point at the top, you're going to divide by 3. So those are cones in any type of pyramid. All right, so this one's a little easier because it's just 10 times 10 times 32. All right, if you plug that in, it gives you 3,200. All right, now big B. What does big B stand for? It stands for area of the base. We'll look right here. The base of this pyramid is this right here. Okay, so to find that, you do 10 times 10 because it's the same base as that one. Now, the height of the pyramid, that's going to be from here down. Now, do I have that? Nope, I do not have that. Okay, so I've got to play around with this right here. Okay, I've got this triangle. We've talked about right triangles. All right, I'm going to bring it out right over here. Okay, we know this outside is 12. Now, if you notice this base right here of that triangle, it doesn't go all the way across. It's only halfway. So think about halfway here. If you said it's 5, you're correct. Now, I've got to find the height. So we got to set up Pythagorean theorem. You take your 2 legs, 5 squared plus 8 squared, and set it equal to 12 squared. Remember to multiply this out first. Okay, so you're going to say 25 plus 8 squared equals 144. All right, subtract 25. So when I do that, 144 minus 25 gives me 119. All right, and what do I do to get the square off? All right, I take the square root. If you're using this type of calculator, And I'm sorry, the thing is actually, it's a little lagging a little bit. So to get the square root, I wanted in my calculator, if I hit the second, and then x squared. All right, and then type 119 in. All right, it's not a nice number. Keep a couple decimal places. So here, h equals 10.90, I'll say 9. All right, so I'm going to put it right here, 10.909. All right, so now I can throw that entire thing in, 3,200 plus 10 times 10 times 10.909. And what did I miss? I missed divided by 3. All right, and so I can say divided by 3. And here it divides just this part by 3, not the 3,200 when I write it like that. So my answer comes out to be 3,563 point. We'll round it to the nearest hundredth. Okay, hundredth is 2 decimal places. That's 0.63, but there's a 3 behind, so it just stays. All right, we'll say feet cubed since it's volume. All right, so be careful of the missing links. You may have to solve for a missing length at some point. They may not give it to you. And you may have to use Pythagorean theorem. All right, moving right along. Numbers 5 and 6. All right, number 5. The following image is rotated around the vertical line. All right, when you rotate something, remember circular motion. So it creates a three-dimensional shape that has circular motion. So that's going to be like our cones, all right, our cylinders, our spheres, or even a hemisphere, half of a sphere. All right, so here we go. What 3D figure did this one create? It creates a cone. Well, what's the volume? Well, the volume of a cone is pi r squared h. We got to know the radius, and look right here. The radius is 5, so pi, 5 squared. All right, h is 12. All right, and it's not divided by 2. It should be divided by 3. Sorry about that. All right, now if I leave this in terms of pi, so if you're leaving this in terms of pi, don't put pi in your calculator, only put the numbers in there. All right, so if I say 5 squared times 12, and I divide by 3, like this. All right, I end up with 100. Now, let me show you something else about these calculators. You can write it as a fraction. If you say alpha x, all right, and then you say 5 squared, you can put 25 in there if you want, times 12, and then you arrow down, so use these arrows that are right here, arrow down, and you put 3 and press enter. We get the same thing, but it looks like a fraction. So here, I didn't put pi in my calculator, and so I put it in my answer. All right, so it would be 100 pi. That's in terms of pi. So I leave pi in my answer. Now, let's move on to some cross sections here. Okay, when we talk about perpendicular to the base, that means going through. Okay, perpendicular means at a right angle, so at a right angle to the base. So think about if I take this through the top and I did perpendicular to this base, all right, and I cut this in half, what's it going to be? Well, the shape right here is what it's going to be. It's going to be a triangle. All right, in this case, if these two sides were alike, then it would be an isosceles triangle. All right, and I think they are. So we can say isosceles triangle. Now, parallel to the base. Think about it. Parallel is going to be horizontally. So if I just cut the top off of it, what's the picture going to be? It's like there's going to be a rectangle right here. Now, if this was a square pyramid, it would be a square on the bottom. All right, but here, this is definitely a rectangle. All right, moving right along to some more cross sections. All right, let's look at, give me a second. Let's look at number 7. All right, I've got 2 different ones here. Okay, perpendicular to the base. Think vertically. Okay, vertically. If I were to cut this vertical, what am I going to be looking at straight on right here? Well, vertical, if I go straight down, I'm going to be looking at a rectangle. Okay, now, parallel to the base. think horizontally, okay? If I just chop the top off right there and take it off, what am I going to be looking down at? And in this case, it's a five-sided figure. It's called a pentagon. All right, now this one over here, okay, when I'm looking at the cylinder perpendicular to the base, if I cut it this way, okay, cut it in half, I'm going to be looking at a rectangle again. And then parallel to the base, if I just chop the top off and I'm looking at it, so chop the top off here, I'm going to be looking at a circle. All right, so make sure you can visualize and see the cross sections. Now, in parallelogram WXYZ, if you don't see a picture, draw a parallelogram and start at one of the corners and go around. So WXYZ. The measure of angle W is 100 degrees. All right, find the measures of angle X and Y. All right, so here's the thing. You got to know your properties. All right, in a parallelogram, first off, the consecutive angles are supplementary. Okay, and what does supplementary mean? That means they add to 180 degrees. All right, so here, if I take 180 and I subtract 100, that leaves me with 80 degrees right here. All right, so the measure of angle X equals 80. All right, let's talk about angle Y. Well, here we could use the same thing. Consecutive angles, all right, are supplementary, so we can use that. Or we can do like this. In a parallelogram, opposite angles are congruent. All right, that's the symbol for congruent because I don't like spelling it out. All right, so therefore, angle Y is 100 degrees as well. All right, as angle W, because they're across from one another, they're equal to one another. All right, so make sure you know your properties of parallelograms. We're going to get back to it in just a second. All right, now find the volume to the nearest tenth of this sphere. Okay, the sphere's formula is 4/3 pi r cubed. All right, now recognize that I need the radius, but this time they gave this the diameter. How do you know they gave you the diameter? They gave you the full line across. All right, and not just half. So what's half of 19? No, sorry, gave you an odd number. Half of 19, if I divide by 2, is 9.5. All right, so this is my radius. All right, so here we go. We're going to round it to the nearest tenth. So 4/3 pi, 9.5 cubed. All right, so now let me show you in this calculator. I might jump over to Desmos in just a second so you can see that as well. All right, and I apologize for the glare on this. All right, so if I clear this out, okay, if you do alpha x, it gives you the fraction. If you want to arrow out, all right, now do pi. So second and the caret symbol gives us pi. And then parentheses 9.5. Okay, and if you're trying to do cubed, here we don't have a cube button. You just do the caret symbol right here, and it raises it up. And then you put 3 and press enter. So this is going to be 3591 point. And because there's a 6 behind that 3, since I'm rounded to one decimal place, I'm going to raise it up to a 4. All right, and it would be inches cubed. Now, let me jump over right quick. All right, and let me jump over to Desmos, okay, right quick, just to show you this. All right, so here, and you can use your keyboard to type, or you can use this keyboard that's down here. But we can say 4 divided by 3, okay? And if I arrow out over here, now pi, I want you to notice where the pi is down here. Look at the keyboard, I'm circling it. You can hit pi, all right? And then 9.5. Okay, and then if you're doing cube, you do this A to the B, circling it again, and then it'll raise it up, and then you put 3 in. And you can see that this is the same answer that we just got before. Also, pay attention to the keyboard. You got a square root. We used that earlier when we were doing Pythagorean theorem. The square is right here as well. We're not graphing anything, but you can still use this for calculations if you would like. All right, let me go back to that sheet again. All right, and let's move on to the next problem that we have. Okay, this is a cross section and a volume. The following image is rotated around the horizontal line. So I'm going to rotate around this horizontal line. Sorry, I'm going to go into the other one. So here, when I rotate it, think about reflecting, but when I rotate, think it's got to make it circular. All right, so right here, well, what did I just create? And if you need to turn it just a little bit, what does that look like to you? All right, it is a hemisphere. If you write half of a sphere, that's fine as well, but the real name is a hemisphere. Okay, so how do I find the volume? Well, it's the same thing as number 9, except for I got to cut it in half. All right, so I'm just going to come up here. So it's 4/3. Okay, AO, this right here, has a length of 3. So that's actually our radius. Okay, so 4/3, pi, and then 3 cubed. All right, now notice it says in terms of pi. I'm going to divide by 2 as well. All right, so if it's in terms of pi, don't put pi in the answer or in your calculator. Just put the numbers, okay? So here, I'm going to do a fraction, so 4/3, and I'm going to do this in 2 parts. Okay, so here I'm going to say 3 cubed. So if we just had a sphere, it would be this, 36 pi. All right, but we don't just have a sphere. Okay, we have a hemisphere, so I divide that by 2. So divide that by 2, and I get 18. So my answer is actually 18 pi centimeters cubed. All right, moving right along. Some more parallelograms. Okay, MNOP. So this time I actually, or yeah, MNOP. Notice went kind of around a different way. All right, if PN equals 30, okay, this is just kind of like an open-ended problem. This whole thing equals 30. What are some other things you can say about the parallelogram and why? All right, well, one of the things is I know that the diagonals in a parallelogram bisect. All right, so if it's just a parallelogram and I know this whole thing is 30, then I know this is 15 and 15. Let's give this a letter of x. So I can say px equals 15, and I can also say xn equals 15. All right, but do I know anything else? Let me finish my thought, each other. These two are congruent to one another. Now, the thing is, if it was a rectangle, then I could say these equaled 15 and OM equals 15, but I don't know that. All right. Here in a parallelogram, OM can be different from PN. Okay, so this is about all that we can say with a parallelogram. All right, now there's a couple more with parallelograms right here. We want to find W and we want to find Z. So right here with W, opposite sides are equal to one another, or opposite sides congruent. So to find W, 4W plus 8 equals 5W plus 1. All right, subtract 4W. 8 equals W plus 1, and subtract 1. All right, so 7 equals W. So that's one of them. All right, and the reason is opposite sides are congruent. All right, well, what do we know about these angles for Z? And that's a minus right there, by the way. All right, well, here, consecutive angles are supplementary or add to 180. So when I go to add 9Z minus 12 plus 3Z, I need to equal it to 180. Add 12, so I get 9Z, or actually equals, that's going to be 192. And now, how do you get Z by itself? You divide by 12. All right, so 192 divided by 12 gives me 16. So Z equals 16. Now let me show you, you could do this, and I'm going to show you this in Desmos. All right, so I'm going to switch over again. All right, here, if you say I'm horrible at solving, you can use Desmos. You can put that 9Z. Now, here's the thing, you have to use X and not Z in here. Minus 12 plus 3X. All right, and this equals 108. Don't put equals or 180. You have to put Y equals 180. All right. Now, the problem is you're finding where they intersect at. Now, 180 is way up here. You can zoom out. You can even use your fingers on, since you got touch screens. And right here, find where they intersect. The 180, don't worry about 180. We just want the X value, and it's 16. Isn't that what we just got for Z? And if you want to do the same thing for W, all right, one side of the equation was 4X plus 8. All right, press enter and then say 5X plus 1. Don't use W, use X's in here. All right, so now zoom out, okay? Right here, I see where they intersect. Again, you don't want the y value, you want the x value. So what didn't w equals 7? And that's correct. All right, so you can check your answers this way. You can also solve it that way. Now I'm going to solve the rest of them by hand so you can see that, but Desmos is an option for you. Let me get back to the other screen though. And let's solve. All right, here we go. All right, so here, and these should probably say these are all parallelograms, but here, these are equal, bisect each other. So for y, we're going to say 4y minus 2 equals 22. All right, so I'm going to add 2. All right, I get 4y equals 24. And then the last thing I do for y is I divide by 4. So y equals 6. And again, you can put one side into Desmos, put the other side, just make sure you put y equals with 22 and find where they intersect. All right, now these two are in parallelograms. So 2x plus 8 equals 18. All right, subtract 8. All right, 2x equals, when I subtract 8 is 10. All right, so here 2x equals 10. And when I divide by 2, x equals 5. All right. Now, just be careful if they ask you for a certain segment and they want you to plug it back in. All right. Because say if they wanted this segment right here, what if I call it XO? Okay. If I want the measure of segment XO, what I would do is I would say 2 times, we found X to be 5 plus 8. All right. And I get 18. Now, we should already know that since that's 18, but you can also check it that way as well. All right. Now, this one, again, this is a parallelogram. Okay, use your properties. Right here, opposite angles are equal. All right, so 102 equals 4y plus 2. Subtract 2. So I get 100 equals 4y. And when I divide by 4, what's 100 divided by 4? You should be getting 25. All right, and this one right here. Remember when you have parallel lines, okay, your alternate interior angles are equal to one another. I like to draw a Z. So that 2x minus 1 equals 29. Okay, so when I add 1, 2x equals 30. And when I divide by 2, I get x equals 15. All right, a couple more. Okay, going back to density now. 15, a block of wood has a mass of 180 grams. It is 10 centimeters long, 6 centimeters wide, and 4 centimeters thick. Okay, what is its volume of density? Block of wood, we're going to say this is a rectangular prism, and they give you this. Now, remember, density is mass over volume. I have the mass, which is 180. I don't have the volume yet. Well, think how you find the volume of a rectangular prism. 10 times 6 times 4. All right, and you get 240 when I go to multiply that. So the density is going to be 180 over 240. So we found the volume, okay? Volume is this. Make sure you label which one's which. All right, so now when I do 180 divided by 240, I get this to be 0.75. And notice what you did. You did grams over centimeters cubed. So this is the density. All right. Now, in number 16, this one's a little bit different, but it is still a density problem. In Mecklenburg County, there's approximately a deer population of 24,000 deer. If Mecklenburg County is about 528.6 square miles, what is the density of the deer population in deers per square mile? Okay, so here we go. Deer per square mile. We're putting the deer on top. That's going to be kind of like our mass. Okay, and then our volume is like your area. Okay, and notice it says deer, so this is deer. This is square miles, so the miles squared, think of it that way. All right, and you're satisfying what the units should be. So if I take 24,000, and I divide it by 528.6, all right, it is 45.4 approximately deer per square mile. All right, moving right along. All right, number 17. The mass of a regulation NBA basketball is 0.625 kilograms and has a diameter of 9 inches. What is the density in kilograms per inch cubed of the basketball? Round to the nearest thousand. All right, think about a basketball. What's the shape? It is a sphere. All right, here, remember, density equals mass over volume. I have the mass, which is 0.625. I just don't have the volume. So the volume is 4/3 pi r. Oh, wait a minute, they gave us the diameter. So the radius is 4.5 and then cubed. What is it to the nearest thousandth? That's 3 decimal places. So first off, finish finding the volume. All right, so 4/3 and then pi. I don't want it in terms of pi, so I'm going to plug it in. All right, this comes out, and I'm going to keep a couple decimal places, 7035. All right, because that's not my final answer yet. And now I can plug this in, 381.7035. All right, so now I can find the density, 0.625 divided by 381.7035. All right, and look here, to the nearest thousandth, that's 3 decimal places. All right, so that 6 is going to change that to a 2. So this is approximately 0.002. And I did, if you want dimensions, it would be kilograms per inches cubed because the volume would be in inches cubed over here. All right, number 18. The density of milk is this. This time we're given density. A dairy farmer wants to sell a container that holds 3,785 grams. That's the mass. All right, what is the volume? So they're giving us, I'm plugging into this formula, 0.028 equals 3,785 over the volume. What is the volume of the smallest container that's going to hold this amount of milk? All right, so here we go. Here, if you multiply each side by V, all right, I get 1.028 V equals 3,785. Now get V by itself by dividing by it. All right, so in my calculator, 3,785 divided by 1.028. All right, so this is 3,681 point, and I said to the nearest hundredth, so 2 decimal places, 91. All right, and this is volume, so it's in cubic centimeters. So that's the volume of it. All right, now number 19. What is the volume of the figure when rotated around the vertical axis? All right, so here, first off, you're going to reflect it and think when you rotate it, it rotates into a circular figure. All right, part is a cylinder. All right, this volume of a cylinder is pi r squared h. All right, so in this case, the radius is 2, and we're going to count the squares just 1 centimeter apiece. All right, the height is also 2. All right, plus, because I'm just stacking these on top of one another, the cone. Cone is pi r squared h divided by 3. Okay, so pi. Now the radius of the cone is the same thing. All right, so 2 squared. Now the height of the cone is a little different. If you count the blocks, 1, 2, 3. All right, but then we're dividing by 3. Now I'm going to write this in terms of pi. Now you can do this in your head because what is 2 squared? 4. Okay, 4 times 2 is 8. So this is 8 pi. Plus, now if you notice these 3's cancel. So now it's just 2 squared, which is 4. And so this whole thing comes out to be 12 pi. All right, and it'd be centimeters cubed. All right, and number 20, name as many properties of a parallelogram that you can name. All right, we'll label, but opposite, sides, congruent. Whoops. All right, I suggest pausing this and see how many you can name on your own and then come back to it. All right, opposite, angles, congruent. All right, so this side is equal to that, that's equal to that. This angle for opposite angles congruent, like this angle is equal to that. This angle right here is equal to that. All right, opposite sides, parallel. Parallel is these double bars. So we use the arrows for parallel, like that. Diagonals bisect each other. All right, so when that happens, and I'll just draw it right here, when the diagonals bisect each other, this part is going to equal that part, and this part right here is going to equal to that part. All right, here, if you remember, the consecutive angles are supplementary. All right, they add to 180. All right, trying to think, anything else? I think we got it. In a rhombus, these are perpendicular to one another. In a rectangle, the angles are 90 degrees. We don't have 90 degrees in a parallelogram. The diagonals are equal to each other in a rectangle, but not necessarily in a parallelogram. So I think we got everything. All right, so make sure you study it. Make sure you are familiar with your formulas. You know how to find things. You know Pythagorean theorem. Know about rotations, cross sections, densities, all your volume formulas, and your parallelograms, and so forth. All right, study up for your test.